Hi, welcome to this lesson on trigonometry double angles. Let's have a look at question 6. Find the general solution to sine x times sine 2x plus cos 2x equals 1. So, from our double angle identities, we know that sine of 2x is 2 sine x cos x, and cos 2x can be written in one of three variations. So it's cos squared x minus sine squared x, 2 cos squared x minus 1, or 1 minus 2 sine squared x. Okay, so let's go ahead and simplify this. So I have sine x, and then sine 2x I can write as 2 sine x cos x, plus, now I got to be smart about the way I choose the variation, right? So because there's a 1 on the right hand side here, I'm feeling one of these two. So maybe I can cancel terms over. And I'm thinking of using this one here because it has a positive 1. Then I can just subtract that positive 1 from both sides and get 0, which is always nice in equations. So I'm going to use 1 minus 2 sine squared x. So the angle you choose, or the variation of the double angles you choose, are very important in the simplification of your trig problems. Okay, so now this becomes 2 sine squared x cos x. Once I multiplied all the terms together, this becomes plus 1 minus 2 sine squared x equals 1. So I can subtract 1 on both sides. So I'm left with 2 sine squared x cos x minus 2 sine squared x equals 0, which is always great when you're solving trigonometric equations. And I see a common factor of 2 sine squared x. When I pull out, I'm left with cos x from that term, and there's just 1 amounts here. So minus 1 equals 0. So we have two equations to solve. Okay, so by the zero law of algebra, this factor must be 0, or this factor must be 0. Okay, so we have 2 sine squared x equals 0, or we have cos x minus 1 equals 0. And if I add 1 to both sides, I have cos x equals 1. So here's two trigonometric equations which we can solve. So for the first one, if I divide both sides by 2, I just get sine squared x equals 0. Okay, and then if I take the square root of 0, I get plus or minus 0, which is just 0. So there's only one equation to solve here, sine x equals 0. And this we can see very clearly if we are very well versed with our parent graph for sine x. So we know at 0 degrees, 180 degrees, 360 degrees, and so on, every 180 degrees you're going to get a 0. So therefore the general solution here is x equals k times 180 degrees, where k is an integer. So that's the general solution. Cos x equals 1, again, if we know the graph very well. Okay, so at 0 degrees it's 1, at 360 degrees it's 1, and so on. Okay, so the general solution here would be x equals 0 degrees plus k times 360, so just k times 360 degrees. So these are the two solutions. But this solution here will capture all the solutions there. Okay, because you're going to get also 360 multiples as you carry on. Okay, so the very final solution will just be this one here, because all the solutions that you find here will also be here as well. All right, and you can test it, right? If you take k equals 0, then you get 0 degrees on both sides. So if we plug in 0 degrees into the original equation, do we get 1? Let's go ahead and check. So sine of 0 times sine of 2 times 0 plus cos of 2 times 0, we get 1. Awesome. What happens if I put k equals any integer, let's say 7? Then I'm going to have 7 times 180 degrees, or I could do 7 times 360 degrees. Both would be valid solutions. So again, we can double check. So I'm going to put here 7 times 180. It's going to be 2 times 7 times 180. And this is going to be 7 times 180. 1. Alright, and if I even put 360 degrees here, you'll see it'll work. Okay, so any integer multiple will work. Alright, so that is the final general solution here to this trigonometric equation. Alright, I'll see you in the next one.